So we want to express 4x squared plus 8x minus 5 in the form px plus q all squared plus r, where p, q and r are constants to be found. This is a process called completing the square, but you probably haven't been taught completing the square in this particular course, so you can do it by comparing coefficients. So I'll show you that, and if you know how to complete the square, then fine, you can do it that way. So 4x squared plus 8x minus 5 is going to be p into x squared plus 2qx plus q squared plus r. So that's px squared plus 2pqx plus pq squared plus r. So comparing coefficients, we can see that p is equal to 4 straight away, coefficient of x squared. Now, we can then look at the x terms, so 2pq must be equal to 8, and if p is 4, that means that q is equal to 1. Now comparing the constant term, so we know p is 4, we know q is 1. So pq squared is going to be 4, plus r must be negative 5, and so r would be negative 9. State the coordinates of the vertex of the modulus of 4x squared plus 8x minus 5. Now we can get this from completed square form, and there's other ways that you could do it. You can differentiate to find the turning point and so on. You just differentiate without the modulus and then just reflect the thing if it needs reflecting. So from that form though, we have 4x plus 1 squared take away 9. So the minimum value of this happens when x is equal to negative 1, because that's what makes this one 0. So if x is negative 1, let's just say y equals that for a second, then y is going to be negative 9, because this will become 0. Now if you think about the modulus graph, that would be down here, but when we do the modulus, we reflect it upwards. And therefore it's going to be at negative 1, 9. And on the axis below, we want to sketch the graph showing the coordinates of the points where the curve meets the axes. Okay, so think about, maybe I should do this a bit more off to the side. Think about 4x squared plus 8x take away 5 equals 0. I think there's a good chance we can factorize that. So if we go for 2x and 2x, 5 and 1, and make this one a plus and this one a minus, that will do the trick. So what we're going to get is x-intercepts at negative 5 over 2 and a half. So negative 5 over 2 and a half. And so if we're just thinking about the 4x squared plus 8x minus 5, it's a quadratic, and it's going to be this way up because of the coefficient of x squared. So it would go like, basically it will go like this. But we know, because we're doing the modulus, that we'll get this reflection upwards. So it's going to come down there. Now, when x is 0, the intercept would be negative 5 down here. But of course, that's going to reflect upwards. And we know that the turning point is going to be at negative 1, 9. So we can put that on here. So it's going to come up and then down, and it will now cross there at 5. And I could have made a slightly better job and tried to make it look more symmetrical, but I think we've got the major features on there.